Welcome to the part 6.2 of the SwiMove course. In this lesson, we'll talk about heterogeneous collections. And first of all, we'll give you the introduction to the heterogeneous collection. Then we're going to talk about the bag type, and also the example of it. Alright, let's start with the introduction to heterogeneous collection. In Sui, heterogeneous collections are essential when dealing with objects of varying types, or when the types of objects are unknown at compile time. A prime example of such a heterogeneous collection in Sui is the bag type. So let's talk about the bag type. So what is a bag? A bag is a heterogeneous map-like collection in Sui, similar to table, but can hold the key-value pairs of different types. Keys and values are not stored within the bag type, but are stored using the Sui object system, and the bag structure acts as a handle into the object system to retrieve those keys and values. Okay, let's say the comparison between the bag and the table. The first one is homogeneity and also heterogeneity. So table is a homogeneous collection, and that means all keys and values in a table must be the same type. On the other hand, bag is a heterogeneous collection, meaning that it can hold objects of different types, or objects of types that are unknown at compile time. This makes it more flexible for applications where the types of objects can vary. And for the type specification, when creating a table, you need to specify the types for the keys and values, whereas when creating a bag, you do not need to declare any types upfront. Types of the key-value pairs being added to a bag do not need to be the same. And for the storage, both table and bag do not store the keys and values within their own value. Instead, they use the Sui object system for storage. And the structure only acts like the handles. And lastly is the operation. The function for interacting with the bag collection are quite similar to ones that interacting with the table collection. Both of them support operations like adding key-value pairs, removing pairs, borrowing reference to values, checking if a key exists, and getting the numbers of the key-value pairs. So in summary, if you know all the objects you need to store will be the same type, a table would be suitable. But if you need to store objects of different types, or if the types of the objects are unknown at the compile time, then a bag would be more appropriate. Okay, let's see a code example. Let's consider a game where we have a game inventory that can contain items of different types. We'll use a bag to store these items. This smart contract module will provide a basic structure and operations for manage a game inventory system, such as creating an inventory, adding and removing items, checking if an item exists in the inventory, and getting the size of the inventory. So the module begins by importing the necessary components from the Sui standard library, including the bag collection and also the TX context for transaction context. The structure game inventory is declaring a structure and has only one single field, which is a bag type. So this structure could represent an in-game inventory, where items is a container and also holds the actual items in the inventory. And this provides a public function named create that creates a new empty game inventory. It takes a mutable transaction context and returns a game inventory with an empty bag here. Okay, we have those two functions, add and remove. Let's see the details of them. For the add function, it takes three parameters. The first one is a mutable game inventory, which is a reference to the game inventory object. And then we have a key for the generic type K, which must satisfy the copy, drop, and store capabilities. We also have the v, which is the value of generic type v, which also must satisfy the store capability. And this function will call to the back add function and passing a mutable back reference, also the key and v. And this function adds a key value pair to the game inventory. For the remove function, it takes a mutable reference to the game inventory object, also the key of the generic type k. And this function returns a value of the generic type v. So this will also call a back remove function, passing a mutable back here and also the key. This function removes the key value pair from the game inventory and returns the value associated with the key. Then we have the borrow mutable function and also the contains function. So for the borrow mutable function, it takes a mutable game inventory reference and also the k. So this function will call the back borrow mutable function, passing a mutable back reference along with the key. This function returns a mutable reference to the value associated with the key in the game inventory. We also have the contain function. So contain function will take the immutable reference to the game inventory object and also the key of the generic type k. For this function, it will call the back contains function, and this will check if the key will exist in the game inventory in a game, and treating the game inventory as a key value store. Lastly, we have the length function. So this function will provide an operation to retrieve the size of the game inventory, that is, the number of the key value pairs stored in it. And that's basically it. So we have go over the heterogeneous collections and also the back type and some code examples of it. And I hope you enjoyed it.